This is fats and sweets. That's right. What's the teenager food triangle? I can't even read that. What does it say? 139. I love that. Does it say jewels too? Pat yourself on the back. Teenager food triangle. Soda. Potato chips. There you go. Yeah. Red Bull. Energy drinks. There's the teenage food triangle. You know, the food pyramid. I know you might argue that some of those things are not actual food items, but there you go. And then it's jewels. It's a J. Are we ready for the next one? Oh, we're ready. Oh, we're ready. Newton meters, a joule. Chain link fence. 132 joules of work lifting a box 1.56 meters. What's the weight of the box? That's the weight is the force. I know we're not clear on that concept. It's the force of gravity. I don't need the mass of the box in kilograms. I need the force in newtons that she exerted. There you go. Yep, yep. So it's like, what's the force? Yep, yep. Science. Yes, yes, yes. Newtons? That's beautiful. I get like a slightly different number. That's right. That's right. I get like 84.6. Maybe you mashed a number. There you go. Yes, yes, yes. Yeah. We must get you a better pen. That's right. Johnny, 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 Nick, Johnny, Nick, Johnny. That's right. There you go. There you go. Are you ready for the next one? Next one, next one, next one, Bobby. This is supposed to be Bobby Socks, but somebody said it's pronounced Sacks, so the joke kind of falls flat. She's pushing a sofa. How far? 2 hints if you need them. That's not really very good hints. In fact, I think they confuse you more. I got a banjo song going on in my head. I don't know about you. Yeah. No, I don't get that number. There you go. You got it. You got it. There you go. Yeah. Yeah. There you go. There you go. Yep. 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 Yes, yes. Yeah, you got it. There you go. That's what's taking you so long.
I know.
You gotta do the bubble letters.
It's trying to
That dog will hunt.
have some creativity. Oh, your dog's talking. This dog.
There you go. Are we ready for the next one? Oh, we got a little lesson. So put the caps on your pens. Okay. So one of the things we can do, and we often do this, right? Sometimes the force that you exert equals the weight. Okay. So for example, if I was lifting 4 kilograms, 1.5 meters, right, then I would have to calculate the force I'm using first, and then I'd have to calculate the force I'm using, and then from that calculate the weight or the work. Sorry. Okay. So concept 0, right, is that this 4 kilogram mass has a weight of, so I'm going to go 4 times 9.8. I get 39.2 newtons. All right, so that's the force I'm exerting. I lift it 1.5 meters, so my work is equal to force times distance, so it's 39.2 times 1.5. In fact, you could just throw it all together. You could just say it's m times g times the height that you lift it. Yeah? I get 58.8. Yeah? And then sometimes you actually don't lift it, you drag the thing along the surface. Gentlemen. Okay, so it could be that we're going to take something and drag it along the surface, right? And we've got a coefficient of friction and we've got a distance. So then we've got to figure out the force of friction. And just remember that that's just mu times m times g, right? And so if I dragged a weight of 5 kilogram mass, so 5.0 kilograms, the force is going to be mu times m times g, right? That's what it always is. So 0.26 times 5. Guys, can we talk when we're whiteboarding and not talk right now? So 0.26 times 5 times 9.8. I get 12.74. Right, and then it's 3.5 meters, so the work is going to be force times distance, so it's 12.74 times 3.5. 44.59. Yeah. So you can make like a table of all the possible forces. Sometimes it's mg if you're lifting, it's mu mg if you're dragging, right? We could add that to this, couldn't we? Okay. Force. Force is if you're dragging, it's mu times m times g, right? If you are lifting, it's m times g. I suppose you could be accelerating something, right? You could be just like, we almost never solve these, right? But it could just be m times a, right? If we're accelerating something. There's a reason why we almost never use ma, but you'll learn it in a little bit here. So let's try. I've got some whiteboard problems where you can try some of these. Look at that. Helena. Hand basket. Yeah. Okay. 5.2 kilogram box. So clearly the force here is not 5.2 kilograms, right? The force is going to be what? 5.2 times 9.8, right? And then 1.45 is our distance. But there's something else that's tricky here, right? She's not lifting the box up. What's she doing? She's actually bringing it down, so she's not doing positive work so much. Should be negative, yeah. Right? You can just slap the minus sign on there. Or if you want to, you can take the cosine of 180 if you want to. Yeah, that works.